This is video 3 in the Packer in the Cloud series. In this video, we're going to walk through building custom Linux and Windows images in Google Cloud using HashiCorp's Packer tool. Just like in AWS and Azure, we start by building two images, one for Linux and one for Windows. For the Linux image, the process is very similar and familiar at this point. We are starting with a Ubuntu 2404 image, and we're going to provision the system over SSH. We are going to run a series of bash scripts that are going to install Apache and then set up a collection of lightweight HTML games that can run as a basic web server. The Windows image requires a bit more setup. We're going to start with the Windows 2022 server image from GCP. Now, in Azure, you get the entire WinRM setup for you. And AWS, you have to do everything. GCP is somewhere in the middle. They do a lot of the configuration for you. They start the service, they provision certificate. You just have a couple of final things you need to do in the metadata startup script of the instance to set the password for the WinRM user and to also set it in the right group. Now, once we boot up that image, we're going to essentially do the system updates. So we're going to patch it, the OS, to the latest level at the time of the build. And then we're going to install Chrome and Firefox. So at the end of the process, you're going to get a desktop that has Google Chrome on it, Firefox, and Edge. Edge is deployed with the Windows 2022 server, so I don't need to do anything for that. Another GCP-specific thing with WinRM is you need a firewall rule to enable port 5986, the control port for WinRM. It's not open by default. Packer doesn't open for you. You have to add a tag and make sure you deploy a firewall rule that will allow that. And the way you will see that if that's not working is it will just hang. It'll get to the point where it's waiting for WinRM to start up, and then it just hangs forever. So once we finish with the Windows image, we have to again run Sysprep. Now we have to call it directly. There is no EC2 launch tool type of thing. You do it manually, and the options are slightly different for Azure, but pretty similar. Also, as a part of the build process, we're going to provision a local Packer account in both the Linux Ubuntu image and also in the Windows image. And we're going to store the credentials. We're going to generate a random password. We're going to store the credentials in Secrets Manager. So when we do the demo, you'll see us go through and connect with RDP and use the secret to get the password. Now, after the images are built, we're going to deploy two compute engine instances using that image. Of course, the games image with a public IP address, and then the desktop image with a public IP address. At the end of this project, you should have a complete end-to-end GCP solution that you can adapt to your own projects. Okay, now let's go through the Packer build process. So it starts with the Packer code, and we're using HCL, HashiCorp control language. You may see stuff on the web that's JSON. That's the old style. The HCL is the more modern programming for Packer. So there's really two parts of the Packer code. The first part is a block that picks what base image and any of the cloud-specific options. And then the second block is a list of provisioners, which ends up being a list of bash scripts that run on Ubuntu and a list of PowerShell scripts that run under Windows. So I'm going to take that code and feed it into the Packer CLI. So the Packer CLI is going to take that first block and pick out the base image and any of the options like the metadata startup for the Windows image. And it's going to start up a window or a VM instance for the provisioning. So for Linux, Ubuntu, it's going to configure a temporary SSH user ID and password, which has sudo privileges, so you can do installs with the apt package manager. And then for WinRM, it is going to, you have to configure that with the metadata start script, and it's going to, you basically have to set the password and put it in the right group. So it's going to provision the instance wait for SSH to become active or WinRM to be active, and then it's going to proceed to the next step. Now, remember, we talked about how you have to have 5986 open as a port with a firewall for this to work with GCP. Port 22 is open by default, so you get that for free. So once the instance starts up, it's going to pass it to the second part of the code block, the provisioners. So for the bash scripts, it's going to do basically apt installations, apt package manager. It's going to copy over the HTML content. It's a very small amount of content. And then it's going to finish. Then for the Windows instance, it's going to provision the PowerShell scope script. Now, here's where you have to be a little more careful with Windows. Bash and Package Manager kind of does headless silent installs for you. It's kind of unusual for it to prompt, whereas Windows installs, they usually prompt. And what will happen is if you don't use the right options here, you're going to end up, the prisoner's just going to hang because it's waiting for user input that's never going to come. So there's a couple ways you can deal with that. The first one is there's a tool called Chocolatey that you can download that does some of this stuff for you, because every installer has quite different options. In this case, we kept it simple. We're just doing 2 installs. So we went and found the silent install options, and we're using the Chrome installer and the Firefox installer. We download it first, and then we run it with the options to run silent install. The other thing with Windows that you have to remember to do is there's a -wait on the silent install. And if you don't do that, what may happen is the install may start, but it won't finish because it'll just immediately exit and go to the create image state. So once all the provisioners run, the PowerShell on Windows, and then the Bash and Ubuntu, and they all have a 0 return code. So if there's any errors, it will not go to the create image. But if it has a 0 return code, it's going to stop the image and call the API from GCP to create the image. That takes a bit of time to take the image. And at the end of the process, it's going to put the image in your project, and then it's going to destroy that VM, that temporary VM that we use to do the entire build process. So now let's talk about the prerequisites to do the build. Now, we have a video out there, which is GCP and Terraform Easy Setup, which goes through the steps for the very simple project. If you've never done one of these before with us, you might want to go use that video. But we're going to assume that you have a Google Cloud account. And in that Google Cloud account, you've created the right build user, which this video will help you out. And then you need the gcloud CLI. The scripting, the end-to-end scripting uses gcloud CLIs to various parts, like get secrets and things like that. Then you also need to install Terraform, and you need to install the latest Packer. So at this point, I'm going to assume that you've done all of that, and we are ready to proceed to the build phase. Okay, so the first step in the build process is you want to copy this code here and go to your Ubuntu development environment or Linux development environment and paste the code in, and have downloaded the project code. Now, the first thing we want to do is we want to run check env, and it's going to say, hey, your credentials.json. You have to have that credentials.json file to make connections. What I'm going to do is, for my laptop, I'm going to drill down into the project, GC Packer. I'm going to upload the credentials file from my local laptop. And now I should try check env again. Okay, so now it tells me we're good. Now, the other thing that's specific to GCP that we need to make sure we do is we have to run API setup. There's a series of APIs we have to configure for the system to build properly. So it's going to enable the APIs for the build. Once the APIs are enabled, now we're ready to start the apply script. So let's do and while it's building, this build takes between 20 and 40 minutes, depending on various options. What I'm going to do is before we wait for the build to complete, I'm going to go back to the documentation and let's go through the build process. So the build process is divided into 3 phases. The first one is we're going to configure the network that we need. And also it's going to also provision it's going to create the random credentials for the Packer account and store it in secrets. Then we're going to proceed to the second phase, and that's where we're going to use Packer to actually build the game's image and the desktop image using the network infrastructure from phase 1. This is where we set the 5986 firewall port so that WinRM will work. And this part of the build takes the longest. It takes about 20 minutes. I've seen it take up to 40. There's a lot of variability on how quickly these things build. And then the final phase is where we're going to, the Packer build succeeded, and we're going to create 2 VM instances, each with a public IP address. And those IP addresses will be one for the games. We'll be able to go into a browser and see the games load in the browser. And then for the Windows Server image, we're going to use the RDP client to connect to the desktop, and we should see, we're going to use the Packer credentials for the desktop, and we should see the 3 desktop icons of Firefox, Chrome, and Edge. And then we'll also bring up check for system updates to show that the system is updated. Okay, the build has completed. So what we're going to do is go back to the documentation and let's take a look at the architecture diagram. It's pretty simple. We have a Google or our cloud project, and then within that project, we've created a VPC and a subnet with Packer. And then we've also deployed the games VM instance, which is based on the games image we built with Packer, and then the desktop VM instance with the public IP address, which is also built with Packer. And then what we've done is we have the credentials that have the Packer credentials where we can SSH to the games VM, or we can RDP to the VM instance. So these exist outside of the VPC. So you get the images, and then you have the Packer credentials. So what we're going to do is bring up the GCP console. So I'm going to go to VM instances, and you can see we've created everything in US Central 1. And we've got the desktop VM and the games VM. So I'm going to go to secrets. And I'm going to click on Packer credentials. And I'm going to say view secret value. So we've got the secret. I'm going to leave this up. So the next thing we're going to do is we're going to test the games HTTP server. So I'm going to go back to my build output. And I'm going to take the games public IP address. We'll copy that. And I'm going to go into a new browser, and I'm going to see, and we've got the games running. And so my favorite, which I've shown in every video, is Frogger. So that's the HTTP server. So let's click on that, and I'm going to let me copy this guy right here, and make sure I copy the right value. And then I'm going to go into the VM instances, and I'm going to click on this guy right here, and I am going to, actually it's the games that I want, and I'm going to SSH. So if I do who am I, it's going to say it did this for me behind the scenes with the GCP console, but all I really want to do ID Packer, and in theory if I do SSH Packer and localhost.com, yes, and then do a paste this plain text, it should let you in. So I'm now, who am I? I'm Packer. And so I have sudo here. I can do sudo bash. I can go and do system cpl status. I can type it right, Apache 2. And then I can go to var www, and that's where I loaded in the HTML content. So that's the stuff that I got from GitHub, the games HTML. So we've logged into the instance. We've used the Packer credentials. So there's a local Packer credential command. So let's exit out of here. So to test the Windows RDP instance, what we're going to do is first copy the external or the public IP address for the Windows version. And then you're going to want to bring up the remote desktop connection dialog. I'm going to put in the address, connect, and I'm going to say more choices, use a different account, hacker, make sure I got it right. Now I hit OK. And it's going to load in the desktop environment. And so you see in the desktop environment, we've got the 3 desktop icons. It's just the Google Cloud Shell, which is unique to GCP, but that's just part of their base image. We have Firefox, Chrome, and Edge. So the last thing to check here is the check for updates. So I'm going to do check for updates. And you can see we just updated it, and we're not working that late. This is in UTC time. So it's the updates were applied and we're as current as the build environment. The only other thing is I wanted to show you, I provisioned in the AMI a startup script, and I'm going to check and see if that runs. And this is often dangerous for a demo. I'm going to go in and go to disk and mcloud, and there we have, I have a boot script. And it is the Packer provision boot script RAM. I put it in the metadata startup script for this instance. And so that we've tested that out as well. So that is it for the demo. The idea is you can take this code and adapt it for your own use, put it in your own projects. And what I'm going to do now is I'm going to be a good steward of my cloud account. I'm going to close this. And I am going to destroy. Now let's talk about the GCP specific issues. First, WinRM. WinRM configuration for GCP is somewhere in between AWS, where you have to do everything, and Azure, where you don't have to do anything, it just does it all for you. So for the most part, when you start up a new instance, a Windows instance, it's going to initialize GCP and add the certificate properly. There's just a couple of last mile steps in the metadata script of the boot for the VM, where we set the password and then move the user into the appropriate administrators group. Next, we do have to Sysprep. Those are slightly different than Azure, but it's a very similar process. There's no like EC2 launch tool where you can go in and it wrappers it for you. You call Sysprep directly. The next issue is, remember, you have to open the WinRM traffic port 5986. The other providers open up the right ports, and for GCP, you have to add the firewall rule and set the tag in your Packer code to apply it. The next issue is not really specific to GCP, but it has to do with the provisioners and uploading content. Yes, you can upload content with Packer for the provisioners, but it's really slow. It's particularly slow on Windows. And so if you have a installer that you want to try to upload and it's a couple hundred megabytes, it's not going to work. You need to figure out another way. And typically what you do is you download the installers dynamically. So you can use tools like Chocolatey that'll automate this for you. But the other thing you can do if you have custom installs is you can create a storage bucket, put all your installs in the storage bucket, and then in the provisioner, use the gcloud command to pull down the installs and run them that way. So that's the most common approach, particularly if you have custom installs. Finally, you notice at the end of this, the DNS name was an IP address, and there was no DNS name is the point. There was just a raw IP address. The other providers provide DNS names on the public IP addresses dynamically within the cloud provider's namespace. GCP doesn't do that. I expect you to register your own domains and do CNAME records or A records in your DNS server to do the routing. I'm planning on doing a video on that because it keeps coming up, doing a sort of a domain registration for each one. But that's why it doesn't work for DNS for GCP. They're expecting you to do that process, which is what you would do anyway. The domain level, theme levels, and the other providers were just sort of convenience things to get things started. You'd never actually use them in real life. So that is it for the GCP specific issues.